Hello, 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 hello. Everyone. How's it going? Today we are streaming Huffman Encoding, and the main reason why I'm live, honestly, is the main reason that I'm live tonight is I I got a dual monitor setup finally. I was always thinking about it. I was first thinking if I should get a big 32 inch, if I should get a dual, if I should do this, if I should do that, and then I just got the dual monitor with arms and shit like that. And so there's a vertical monitor here where I'm trying to monitor my OBS and chat. Then there is a I look fat. Anyways, then there is my main monitor which I'm working, and I want to see how efficient it is to actually like if you really have productivity outputs, right? So without further ado, let's get started. Okay, okay. So the question is, how does it show screen? We'll see. We'll see. We'll see. Okay. Hmm. Okay, so we were doing Huffman compression, and let's first rename this to an encoding, or let's just say encoder. Here we can say encode, yeah. No, we can say encode. So what we were doing last time is that yeah, we generated the map, right? So we generated the map, and if we keep on running this program, I think we can see the map. Yeah. So so this is basically the map. So I remember last time we were thinking about how we can encode the map and how we can encode the data. Right? There are two things that we have to work on. One is how do we encode the map, how do we encode the data. So one of the things we want to do is we want to encode that okay, 0 is S, 110 is this, and this is this. And we also want to do this thing where we want the other way around. So we want to keep the table in a binary format, saying, okay, this is a table which can be helped to decode the data. Sorry, and then to encode the data, you need this. And the ideal way would be to actually pass in the data along with it, right? But if you pass the table along with it, kind of increases the entire point that okay, now you have to. Um, so I remember we were looking at this. Yeah. So we are looking at this in here. Right? of annoying to have a second monitor, honestly. I was right, because it constantly keeps going here. I gotta somehow adjust to it. Okay. Hmm. Hmm. Data compression is when the original data is reduced, but the information is mostly fully kept. So lossy or lossless compressions. Sound of music files are examples, stored in compressed format, roughly just 10% of the original data size, but most of the information is kept. Lossless means that even if the data is compressed, all the information is still there. This means that, example, a compressed text file has all the same letters, blah, 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 blah. Creating this thing, yeah. So, okay. So you have a bunch of things in here. And UTF-8 character code has been reduced to this. But if the data is stored with Huffman encoding as this, or let's say it can be, how can it be decoded? So, cat is jumping around. Nice. So how can a computer fully understand? This is my point. How do you how do you push in the table? Just like the code stored as UTF-8, which our computers can already decode to correct letters, the computer needs to know which bit represents which piece of data in the Huffman code. So for this Huffman code, the letter A is this, the letter B is 10, and then sorry, the letter N is 11, 11. It gives you the code and everything. Okay. But this is what I want you to know. This is what I want you to know. Okay. So let's think in this way that first thing is, how do I generate the data? Right. So one of the ways to generate the data would be to say that you have why is a tablet on that screen and not on this screen? But there was a tablet. Uh,
またこれは
okay, so we are back with this. So if we look at our data in this is the data, and I think yeah, so this is the information. One of the things we don't want to do is we want to represent L with only two characters. So 1 1 1 0. Then you can have O, which is 1 1 0. You can have S, which is 0. Then you can have another 0. Then you can have 1 0. Then you have E, which is 1. 1 0, S which is 0. Where did O go? Yeah, this has to be 1 1 1. Okay, so 0 and 0. So total of 5, 8, 9, 10, 12, 15, 16, 17, 17 bits together. If I consider these as bits, right? There are 17 bits together. What I want to do here is that I want to say the
私やっぱり瑛太先輩が好き。
I want to say so if it's 17, we need 32 bits for this. We need 32 bits for this, right? We need 32 bits for this. So the very first thing that we need is L is 1 0. So this is 1 2 3 4 5 6 7 8. So we can start from here. L. So L here is 1 0. So you can say 1 and 0 because the cursor is here. Because the cursor is here. So you say 1 and 0. Then you say sorry. So your cursor is here now. So then you say O, which is 1 1 1. Then you say we can do from other end also, right? We can do from other end also, I think.